All right, in 13.3, let's look at number 4. We have a half 4 and the vector -8, -3. And I want to do A dot B. That's just going to be that times that plus that times that, and it's -16. Number 8. I want a dot 1, no, 0, because there's no I, 4, -3, dotted with 2, 4, 6, and that's going to be 0 plus 16 minus 18, -2. So remember, when you do a dot product, you just get a real number. Remember, also, we can use this formula. So here in number 10, we have 4 times 10 times cosine of 120. Well, cosine of 120 is -1/2, so this is -20. 12. Use the unit vector so if we do u dot v, the magnitude of u is 1. But we have a square here. This is u, and this is v, and this is w. So this is 45 degrees because it's the diagonal of a square. So u dot v is the magnitude of u times magnitude v cosine theta. The angle between u and v is 45 degrees. So magnitude of 1 is u, 1. If the magnitude of u is 1, then the magnitude of v is square root of 2 over 2. Because I have a right triangle right here, this is 45. So the magnitude of v is the square root of 2 over 2, or cosine of 45. So square root of 2 over 2, then I have cosine 45, which is square root of 2 over 2 times square root of 2 over 2 is 2 fourths, which is 1/2. Let's look at 16. Find the angle between the vectors. Well, I'm going to dot. So I have A dotted with B equals the magnitude of A. So that's going to be square root of 3 squared plus 1, square root of 4. Times the magnitude of B. Magnitude of B is 5. Cosine of the angle between them. And that's what we're trying to find. So the dot product of A dotted with B is 0 plus 5, which is 5. So 5 divided by square root of 4 is 2 times 5 is cosine theta. But 5 and 5 cancel, so that's a half. Where's cosine equal to a half? That's at 60 degrees. Let's look at 24. We have to decide whether they're orthogonal, parallel, or neither. In A, if you look, V is -4/3 times U. So that means they're parallel because they're scalar multiplication of one another. So if K U equals V, then they're parallel. That just means they have different lengths, but they're in the same direction. Let's dot these two. That's going to be 2 plus 1 plus 2 is 5. That's not 0. So they're not orthogonal, and they're not parallel since they're not scalar multiplications. So it's neither. And the last one, if you dot them, u dot v is minus ab plus 0 equals 0, so that means they're orthogonal. When the dot product is 0, they're perpendicular or orthogonal. Okay, let's look at number 30. Find the direction cosines and the direction angles. Okay, so cosine alpha is 1 over the magnitude. Remember, it's x1 over the magnitude of u. The magnitude of u is square root of 1 plus 4 plus 1 is square root of 6. This is 1 over the square root of 6, so alpha is 65.9 degrees. Cosine beta is x2 over u, which is negative 2 over the square root of 6. I guess we'll just call that y1. So beta is 144.7. Remember, since cosine is negative, this is in quadrant 2. And then cosine gamma is negative 1, is z1 over the magnitude of u, which is minus 1 over the square root of 6. Again, this is in quadrant 2, so gamma is 180 minus the first one, 65.9, which is negative 114.1. These are in degrees. Okay, 36. I'm going to find the scalar projection of B onto A. And that's going to be A dot B over the magnitude of A. So if we dot A, we're going to get negative 4 plus 2 is negative 2 over the magnitude of A squared of 5. The projection of B on A is that times the vector over its length. So that's going to be minus 2/5 times 1, 2, the vector 1, 2. And last one is 46. Find the work done. If the force is 20 and it goes in 50 degrees, moving the object 4 feet due west. So I have, it's going west 4 feet. Northwest. So there's northwest. So northwest is 50 degrees. So this is 40. And the force is 20 pounds. So that's the work is the force times the distance. But the distance is 4. The force is just going to be 20. That's the magnitude. Cosine theta, which is cosine of 40 degrees. That's the angle. So if you do that on your calculator, this is times. It's going to be 61.3. 3 foot-pounds. Alright, so it's easy to do application problems when you have vectors.